Most discussions about wartime logistics focus on munitions, fuel, and troop movement. Rarely do we stop to consider something as seemingly mundane as how wood, cloth, or even food stores were prepared for use. Yet in the Korean War and in countless earlier conflicts, the failure to manage such basic resources effectively had disproportionate consequences. One overlooked reality is that soldiers and engineers often relied on air-dried materials, timber, canvas, and even grain, rather than the high-tech treatments available at the time, because air drying simply worked better under field conditions. Units that neglected this practice found that wood warped, canvas rotted, and rations spoiled, creating cascading operational problems that cost both time and lives. The choice of method, though it might seem minor at first glance, actually illustrates a broader principle. Understanding natural processes and working with them can, quite often, outperform modern shortcuts, especially in austere or rapidly changing conditions. Air drying was really a deliberate choice, not just a fallback. There is, a persistent misconception that air drying was somehow primitive or inferior, but historical records suggest otherwise. During the Korean War, engineers tasked with building field fortifications often rejected chemical treatments or rapid drying methods because they led to brittle, uneven materials. Timber cut in winter was stacked in ventilated sheds with precise spacing to promote slow, uniform drying. This process reduced internal stress, minimized warping, and prevented cracking. Similarly, canvas for tents and uniforms was air-dried under tension, preserving tensile strength and resistance to mildew. These practices were informed by centuries of empirical observation. Soldiers and craftsmen knew that artificially accelerated methods often produced materials that appeared ready but failed under load or in harsh weather. The physics of why air drying works cannot be overlooked. Wood and textiles are porous, living structures. Moisture trapped in the fibers creates pressure as it evaporates. Rapid drying drives moisture unevenly from the surface inward, generating tension that can crack beams, split planks, or weaken cloth. By contrast, air drying allows moisture to escape gradually, letting fibers shrink uniformly and internal stresses equilibrate. In field studies conducted by military engineers, timber that had been air-dried for several months retained 20 to 30% more structural integrity under load than chemically treated or kiln-dried equivalents of the same species. For soldiers constructing bridges, shelters, and gun platforms, this difference was critical. The principle extends beyond materials. It reflects a broader strategy of working with natural processes rather than attempting to force a shortcut. Air drying was not just a matter of exposure, it was timed. Historical accounts from the Korean War detail how timber cut in late fall or winter, when SAP content was lowest, was far less prone to insect infestation or fungal decay. Winter cutting also allowed for storage through cold months when microbial activity was naturally suppressed, effectively creating a built-in preservative period. Similarly, canvas and rope were harvested and dried in seasons with moderate humidity to reduce shrinkage and mildew risk. This attention to timing actually reflects a level of resource management that's often overlooked in conventional histories, yet it had really direct operational consequences. Units that ignored seasonal timing faced much higher rates of material failure, which ended up compromising both fortifications and logistical networks. Air drying alone was honestly just not enough if materials were poorly stored. Engineers and supply officers understood that, the benefits of slow drying could easily be lost through exposure to rain mud or direct sunlight. So, wood was stored off the ground on stone pads or elevated racks, often under ventilated roofing. Canvas and rope were kept taut and shaded, preventing sagging or mold growth. In Korea, field manuals emphasized that stacked timber must allow airflow on all sides and that air currents, rather than heat or artificial drying, were the principal agents of stabilization. These measures minimized risk and preserved functional integrity for months, even years, without chemical intervention. For survivalist-minded viewers, the lesson is clear. Environmental control and patience often outperform rapid technological fixes. Air drying is as much a human practice as a technical one. It requires patience, planning, and attention to subtle environmental factors. Soldiers and engineers had to anticipate future needs, store materials under optimal conditions, and resist the pressure to deploy hastily. Historical reports indicate that commanders who underestimated the time required for proper preparation often faced cascading problems, collapsed structures, slowed troop movement, or loss of essential equipment. The Korean War thus offers a microcosm of a universal lesson. In both conflict and survival, the discipline to align human activity with natural processes enhances durability and effectiveness. Even today, rapid drying methods, chemical treatments, and synthetic materials are often marketed as superior. Yet in field conditions, these methods can introduce unintended weaknesses. Timber can become brittle, coatings may fail under temperature extremes, and synthetics may degrade unpredictably. Historical evidence from the Korean War and earlier conflicts demonstrates that understanding and respecting the properties of natural materials often yields longer-lasting, more reliable results. Air drying was not chosen for convenience. It was chosen because it produced predictable outcomes that could withstand the uncertainty of war. For historians, the study of air drying offers insight into the sophistication of wartime logistics. And for modern engineers and survivalists, it provides practical lessons in resource management, patience, and environmental adaptation. Air drying illustrates that material behavior is dictated by physics, biology, and context, not solely by human intervention. Observing how our predecessors integrated timing, storage, and natural processes into their work reveals a form of applied science rooted in experience rather than laboratory testing. This approach remains relevant for anyone seeking to create durable, resilient systems under resource constraints. You know, the Korean War context really highlights how small details like properly dried timber and rope can actually have pretty large strategic consequences. Units with reliable materials could construct defensive works quickly, maintain mobility, and sustain operations under harsh conditions. But those without such foresight, well, they faced cumulative setbacks. Understanding why air drying was preferred actually illuminates the interplay between logistics, human planning, and environmental adaptation, offering lessons in preparedness and foresight that really transcend the specifics of any one conflict. Air drying was far more than a historical curiosity. It was a deliberate, empirically tested strategy that shaped outcomes in war and survival. It emphasizes patience, observation, and working in harmony with natural processes rather than imposing forceful shortcuts. Reflecting on these practices, it reminds us that, honestly, human ingenuity often lies not in invention alone, but in careful attention to detail, disciplined execution, and, respect for the materials and environment at hand. These are lessons that remain vital, whether constructing durable shelters, managing limited resources, or while studying historical conflicts in depth. If you value nuanced historical analysis and want to explore more lessons from the past that inform strategy, survival, and engineering, then do consider subscribing to History Matters and sharing this video. Understanding these overlooked practices, honestly, enriches our comprehension of history and equips us to make smarter decisions today.